All right, this is the right triangle and trigonometry review. Let me remind you, when you have two or three sides in a right triangle, you can use the Pythagorean theorem to solve that. I prefer the version c squared equals a squared plus b squared. C is your hypotenuse. It's the side across from the right angle, in this case 8. A and B are the legs, the other two sides. Square each of those values, you get 64 equal to 36 plus x squared. Trying to solve for x squared, subtract 36 from each side. And so you get 28 equal to x squared. And then to get rid of squared, we'll square root. Only a positive answer makes sense here. If you go to a factor tree on 28, you'll have maybe 2 and 14, 2 and 7, or you could do 4 and 7, and then for the 4, 2 and 2. So we have two factors of 2 and a factor of 7 equal to x. And so the exact value of that is 2 square root 7, because we have two factors of 2 there. And then we can go to our calculator. For the calculator, you can either do square root of 28, or you could do 2 times the square root of 7. Either way, if you round it to the nearest tenths, the calculator is telling you 5.29. So 2 is in the tenths place. The 9 tells you to round up to 5.3. Number 2, we want to find BC, so this side over here. But to start with, let's find AC. So if you look at the triangle that has the BC that we're trying to find, we only have one side. So we need to look at the other triangle where we had 2 or 3 sides. So in the triangle ADC, the one that I just labeled as y is your hypotenuse. So y squared equals 6 squared plus 8 squared. So that's 64 plus 36, that's 100, equal to the y squared. To get rid of squared, square root, only a positive answer makes sense here. So we get 10 for the value of y. Now looking at this other triangle, we've got hypotenuse of 26. So c squared, 26 squared equals 10 squared plus x squared. Twenty-six squared gives us 676. 10 squared is 100. To get rid of the 100, subtract 100. So we get 576 equal to x squared. And then to get rid of squared, square root. Only a positive answer makes sense here. So the square root of 576 is 24. So x is 24, or BC is 24. So sometimes you may have to do the Pythagorean theorem more than once. Number 3, we want to find AB. AB is the hypotenuse of this triangle. I'll just call it C for now, lowercase c. So c squared equals 5 squared plus 12 squared. So that's 25 plus 144. So 169, and square root of both sides. Only a positive answer makes sense here. So we get 13 for AB. Now that we have that, it's easy to find cosine. Cosine is adjacent over hypotenuse. So 5 over 13. Tangent, now it's tangent of B, so we're looking now from the other angle. So that's important because the opposite and the adjacent change depending on which angle you're looking from. So now we're looking from angle B, opposite over adjacent. So 5 over 12 for the tangent. Now we're told to find the measure of angle B. Well, if the tangent of B is 5 over 12 and we're looking for the angle, then we do inverse tangent. So B will be equal to the inverse tangent to the -1, of 5/12. So we're looking for the angle whose tangent is 5/12. So second or shift tangent. And then make sure you're in parentheses 5, fraction button 12, or you can do 5 divided by 12. So we get about 22.6, and this should be approximately equal to there. And so if we round it to the nearest whole degree, that's about 23 degrees. All right, here we want to find the measure of angle A. And so we've got the opposite leg and the adjacent leg to that angle. And so we can say that the tangent of angle A is 22.9 opposite over adjacent 14.1. So we're looking for the angle whose tangent is 29.9 over 14.1. So do inverse tangent, second or shift tangent. And so make sure you're in parentheses. Most of your calculators will force you into parentheses there. But if not, put parentheses around the 22.9 divided by 14.1. This time it says to round to the nearest tenth of a degree. So I'm getting about 58.3785, and it goes on past there. Nearest tenth. Tenth is that first decimal place. So the 7 tells us to round up here, so 58.4 degrees. Sorry, and I'll fix that before I print those out for you. But it is the measure of angle A that we're looking for there. All right, here we want to write an expression for the sine of 32 degrees using cosine. Now you'll remember that the sine of an angle is the same as the cosine of its complement. So the sine of 32 degrees will be the same as the cosine of the complement of that. That'll be the remaining angle that makes up the 90. So 90 minus 32 gives us 58. Sine of 32 degrees is equal to the cosine of 58 degrees. And you can even use your calculator to verify that. Make sure you're in degrees. Sine of 32 degrees, it equals, you get about 0.5299. And then you can go in and put cosine of 58, and you get the same value, 0.5299. So you can verify to make sure that those are in fact equal using your calculator. All right, here we've got a 90-degree angle, 60-degree angle, and so this is a 30, 60, 90 triangle. It's one of those special triangles. The short leg is across from the 30-degree angle. That's the x. The hypotenuse is 2 times x. 2 times the short leg. So you can solve for x by dividing by 2. And so x is 14. Now you'll remember that the long leg is the short leg times root 3. So 14 square root 3. So short leg times 2 is the hypotenuse. Short leg times root 3 is the long leg. Your 30, 60, 90. Here's a 45, 45, 90 triangle. The legs are congruent, and the hypotenuse is the leg times root 2. So to solve this, divide both sides by root 2. Now 8 over root 2 will simplify by rationalizing the denominator. Multiply the top and the bottom by root 2. You get 8 root 2 over square root 2 times square root 2 is square root 4, which is just 2. And then we can divide that. 8 divided by 2 gives us 4. So 4 square root 2 is the leg length. All right, here they tell us that AC is 16. So AC and AB are the congruent sides, the legs on a 45, 45, 90. The hypotenuse is the leg times root 2. And then over here you're in a 30, 60, 90. The short leg is half of the hypotenuse. So 16 square root 2 divided by 2 gives us 8 square root 2. For the short leg, that's one of the ones you're trying to find. And then if we multiply that by square root 3, we get the long leg. The long leg in this case is DC. So square root 2 times square root 3 is square root 6. So we have found those two missing sides that we were looking for. Here we have this angle 62 degrees, and then we have this side, which is the opposite leg, and this one, which is the adjacent leg to that angle. Trig ratio that uses opposite over adjacent is tangent, so we can say the tangent 62 degrees equals opposite over hypotenuse, opposite over adjacent, excuse me. We can multiply both sides by x. So we have x tangent 62 degrees equals 71. And then we want to solve it for x, so divide both sides by the tangent of 62 degrees. The tangent of 62 degrees divide out to 1, and then we'll go to our calculator for this decimal approximation. 71 divided by the tangent of 62 degrees. We get about 37.751. Says to round to the nearest hundredth, which is your second decimal place. The 1 will tell us to round down. So about 37.75. Here we're looking for the angle of depression. So it's labeled by x. Now this horizontal line will be parallel to this one, and so alternate interior angles will be congruent. So as far as the triangle is concerned, we're looking for angle F. Well, the trig ratio that uses angle F and the 500 and 20,000 is tangent. So we can say tangent of F is equal to opposite over adjacent. So 500 divided by 20,000. We're looking for the angle whose tangent is that, so we'll do inverse tangent. And it's up to you if you want to simplify that any before going to your calculator. But you can type it in just like it is. We're going to use inverse tangent for this. So we get about 1.43. I'll round up to the nearest tenth, I suppose. So about 1.4 degrees is the angle of depression for this part of the flight. All right, 14. Dante's standing horizontal, ground level, with the base of the Empire State Building. Empire State Building is 1,472 feet tall. we're trying to find the distance. Now we're talking about ground distance here. So trying to find the distance from Dante to the base of the Empire State Building. I guess I'll just call this B for the base of the building. And we know the angle between him and the top of the building is 48 degrees, 48.4 degrees. All right, so from that angle that we know, we've got opposite and adjacent there. So we'll use tangent. So tangent 48.4 degrees is equal to 1,472 divided by x. Trying to solve for x, so we'll multiply both sides by x. So we have x tangent 48.4 degrees equals 1,472. Trying to solve this for x, we'll divide both sides by the tangent of 48.4 degrees. And so we'll go to our calculator for the decimal approximation of that. So 1,472 divided by tangent of 48.4 degrees. If we round this to the nearest foot, we'll get about 1,307 feet. So that's how far he is from the base of the Empire State Building. All right, rocket ship is 3 miles above the ground. So I'll just use for R for where the rocket ship is. So this is 3 miles from the ground. We're going to see this horizon and then 6.5 degree incline there. Begins to climb for the next 70 ground miles. Ultimately, our goal is to find this value, how far it is above the ground. I guess I'll call that y, because we're going to use x in the triangle. All right, so these distances are the same. So this distance is 70 miles. And so the trig ratio that we'll use this angle will be tangent, opposite over adjacent. So tangent of 6.5 degrees is equal to x over 70. Trying to solve that for x. We can multiply both sides by 70. And so we can go to our calculator, get that decimal approximation. 70 times the tangent of 6.5 degrees is equal to about, I'll round it to the nearest tenth, about 7.97. So it rounds up to 8.0. And then if we add that to the 3 that's already here, so 8 plus 3 gives us 11 miles above sea level. So ultimately our goal is to find this value for what I labeled as y, which comes out to be 11 miles above sea level. So don't forget to add the 3 back in because these distances are the same. All right, 7, we've already got a diagram that makes it a little bit easier. We're trying to find the distance from the owner to the dog, and this is a direct distance. So it's this hypotenuse in this right triangle. So the trig ratio that we'll use the 10 degrees and the opposite side and the hypotenuse will be sine this time. Sine of 10 degrees equal to 40 over x. Trying to solve it for x, we'll multiply both sides by x and then divide. So we'll have x sine of 10 degrees equals 40, and then divide both sides by the sine of 10 degrees. So these will divide out to 1, and so we're just left with x equal to 40 over sine of 10 degrees. And we'll go to our calculator for the decimal approximation, and we'll round it to the nearest, I guess, tenth of a foot. So 40 divided by sine of 10 degrees is equal to about 230.35. I'll round up to the nearest tenth, so it'll round up to about 230.4 feet. Alright, so hopefully this video has helped you in your preparation for the test.